So in this video we're going to see a graph theory 2 marks question which is from the paper GATE 2015 and it is based on the concept of bridge. So let's read what the question is. In a connected graph, a bridge is an edge whose removal disconnects a graph. So this is the concept of bridge, a definition of bridge which they have mentioned in the statement. And the next line is, which one of the following statements is true? So we are going 4 options A, B, C, D, and we have to choose the true statement based on the definition of bridge. So first let us draw a simple graph and try to understand what a bridge is. So let me draw a graph here with 1, 2, 3 and 4 and 5 and 6. Yes, let's say I have this graph. You can say it's a graph with 6 nodes. Yes, 6 nodes and 1, 2, 3, 4, 5 edges. Let me draw one more edge here. Okay, now as per the definition of a bridge is an edge whose removal disconnects a graph. So in this graph, if I remove this edge, okay, let me delete it. If I remove this edge, then you can clearly see that the graph has got disconnected, which means that edge was a valid example of a bridge. Let me get it back. Yes. So this is the definition of a bridge. A bridge is an edge whose removal will disconnect a graph. Now based on this concept and based on this simple example of a graph which we have drawn here, let's see the option one by one. Okay. Option number A, a tree has no bridge. Now let's draw a tree to understand this statement. So this will be my tree. Let's say this is my tree, random tree of random nodes and random edges. Now it says that a tree has no bridge. This statement is clearly false because this edge is a valid bridge. If I remove this edge, then the tree also gets disconnected, which is the definition of bridge. So statement number A is false. A tree definitely has a bridge. Let's go to statement number 2, B. A bridge cannot be a part of a simple cycle. So this is my simple cycle here. This is my simple cycle. Can there be a bridge in the cycle? Looks quite difficult because whenever you try to remove an edge from the cycle, the graph will still remain connected because it's a cycle, right? So even if you remove one edge from the cycle, the other nodes will still remain connected. So a bridge cannot be a part of a simple cycle seems a true statement. So let's mark it and keep it aside. Let's go to option number C. Every edge of a clique with size greater than equal to 3 is a bridge. But what is a clique? A clique is any complete subgraph of a graph. Okay. So since they have said size greater than or equal to 3, let's take a small example of a clique. So if we take 3, let's start with 3. So this becomes a clique. Okay. It's a complete subgraph of a graph. Now, is every edge of this tree, of this clique, a bridge? No, because whenever I remove this edge, this still remains connected. If I remove this edge, it still remains connected. So as you can see, since it's a complete graph, if you connect statement C and statement statement C and statement B, they're related. Since a clique will be a complete subgraph, if you remove any edge, because there are edges all over the vertices, so whenever you remove any edge, the other vertices will still remain connected because it's like a cycle. So statement C is also false. Every edge of a clique cannot be a bridge. And then let's come to statement D. A graph with bridges cannot have a cycle. This is false. This is clear from our example here which we took. This is a graph with bridges where this was the bridge, and it says cannot have a cycle. Of course it can have a cycle. A graph can have a bridge and it can also have a cycle. So this statement is also false. So statement number B is the right option.